I'm the co-director of the Grant Park Academy of Arts. We teach music in Atlanta, Georgia, and we teach other subjects as well. I'm also a Feldenkrais practitioner. I've been certified for almost 20 years. And from the beginning of my training, I was very interested in mathematics as something that could be improved through Feldenkrais. And at the end of this presentation, if there's time, I'll talk more about myself if you're interested, but I want to get right to the presentation. Today I'm going to be talking about the idea that when we do math, we are actually moving in an imaginary space, and that notation, math notation, is a way we can better move through that space. It enables us to move through the space more easily. And that through something like the Feldenkrais method, we can better connect to that math notation and improve our ability to learn and to do math. Before I talk about that in particular, I want to talk about two concepts that we use when we are Feldenkrais practitioners. These are relatively new, at least the body schema is. The body image and the body schema. The body image is our image of our body. It is largely conscious, and it is mostly involved with perception. The body schema, on the other hand, is mostly unconscious. It is constantly being updated by the information in our proprioceptive systems, muscles, for instance. And so if you have your eyes closed and you know where your arms are in space, that's the proprioceptive. And your body schema is constantly getting that information and updating itself. And it's more involved with movement. With these two ideas, body schema and body image, I can describe in fairly concrete terms what is happening in a Feldenkrais lesson. When you are on the table or when you're on the floor and I'm giving you instructions and you begin to move, I am activating your body schema. As the lesson progresses, I compare what you're doing to your body image and give you some idealized movement, give you some idea of what perhaps you might want to do otherwise. And your body schema updates. It starts to get new information. And what's remarkable is that at the end of the lesson, when your body schema has finished updating, your body image has changed. Now, this is not the entirety of the Feldenkrais method by any means. This is just a shadow of the method. This is just one little way of looking at it. But this shadow has some interesting characteristics that allow us to talk about something very interesting, this connection between the body schema and the body image. Yes, ma'am?
Can you say again, what are these two things and what is the connection between them?
Yes, I can.
What is the difference between them?
So I'll tell you the best I can. At the end of the presentation, you'll see my sources and you'll be able to do more research. But what I can tell you is that the body image has to do with perception, as in what we see, very eye-oriented, and it has to do with what we know of, what we think of as where our limbs are in space. The body schema has much more to do with how you're going to move, where you're going to do. It's a schema, an idea about how you want to get from here to there. And so these two ideas, the body schema and the body image, they interact with one another all the time. But the body schema does it in a more unconscious level, and when we do a Feldenkrais lesson, we actually have a chance to access the body schema, and we can do very powerful things. Again, I want to emphasize that this very concrete and very small definition is not the method. It is just one way of talking about the method, one shadow of what we're doing. But what's interesting is that the body schema can change the way we think about ourselves. The body schema and the body image interact with one another, and that's why you might want to be interested in it. Because of our body schema, we can make changes to ourselves according as new stimuli comes to us. If something new is happening, we can make a change and we can affect that. Now, the body schema is particularly interesting because we can trick ourselves with it. There was one particular study done in which if you close your eyes and touch your nose, it is possible to vibrate certain muscles and give yourself the sensation that your arm is opening even when it is not. Now, what they found in this study was that people who did this, as they felt their arm was opening, because they were touching their nose, they felt that their nose was growing to a ridiculous length. They had actually tricked themselves. Other experiments have also been done in which the person believes they're in strange configurations that they couldn't possibly be in. Now, they're not in any pain, but they believe their limbs are in strange positions. And this is the body schema without the visual stimulus tricking the body image. And this is very important, that the body schema can take us into imaginary spaces. Now, this is a picture of a rhesus monkey, and it's using a tool. What they found out in this study was that when we use a tool, and it can be anything as simple as a stick or a magic marker, the body schema incorporates that tool into our body so that the tool becomes part of our body. It's no longer something separate. So the brain imagines that the body can reach all these places because of the tools. Before I talk about the musical instrument, I want to talk about one other thing. They did another study in which someone had a stick in this hand and a stick in this hand, and the sticks were crossed, but the arms were not. And people were asked to manipulate objects with the sticks across each other, like this. Let's see if I get my markers back. So they had their sticks, and so they were asked, for instance, to, without crossing their hands, maybe move something like this. What they found in the brain scan was that the brain thought that the arms were crossed. You couldn't see, I'm sorry. So all I'm saying is there are two sticks, arms are crossed, but not, sorry, sticks are crossed, but not arms.
And the eyes are closed.
No, in this case, I don't remember whether the eyes were closed or open in that case. But I do know that the brain registered that the arms were crossed, even when they were not, because it incorporated the tool into the body. Now, when I think of tools as a musician, the first thing I think of is something like a cello bow. So I'm here with my cello, and I'm moving the bow back and forth. And the cello bow is a tool that's giving me extra access to the strings. In fact, the cello is also a tool that allows me to make music. It moves me into this music space that I could not do without it. The question is, what is this music space that this cello and this cello bow are moving me into? Can it be discussed? Well, the extended space involves things like the concept of going up. That's one movement that you might hear about in the music space. You may be familiar with the concept of singing up and singing down. As a conductor, I sometimes would give beats like this, where I'm waving my arm around like this, and then I may be asking my choir to get louder and softer. So these are all physical movements, but these movements have nothing to do with what's actually happening in music. When I say go up on the piano, I'm going to the right. I'm not going up. And when my voice, nothing is happening but the constriction of my vocal cords. There's nothing going up at all, nothing going down. And this concept of this beat, 1, 2, 3, 4, this is just a convenience. It's just something I use to show my musicians where to go. And yet, we describe music in these movement terms. In the same way that we might describe this, can somebody tell me what this is a picture of, please? Raise your hand, or yes, a cube? No, this is not actually a picture of a cube. This is a picture of, I believe, a hexagon with lines inside. But we don't see the picture, we don't think of it that way because it's much more useful to think of this as a cube. In the same way, we don't think about whether we're actually going up or down with movement, with music. We simply use those movements as a convenience to understand what we're talking about with movement. This is a convenient picture of a cube. And in fact, it is a shadow. It's not actually a cube at all. We know that because cubes have right angles coming from each corner. And these are clearly not right angles. This is just the shadow of a cube. If you were holding a cube up, shining a light through it, you would see the shadow. And yet it is sufficient for us, this shadow, to give us a sense of what the cube is. This is a cute picture over here. You can see that the shadow says think. This physical object is much more complicated than that, and yet it does give us an idea. So if we had a number of shadows of the cube, but we're familiar with cubes and we hold them, but if we didn't know what a cube was, we would want a lot of shadows of cubes to give us a sense of the cube. And yet the shadow is enough to give us a sense of what's going on. Now, you may be thinking to yourself, okay, we're talking about imaginary spaces here, but everything you've done has a physical gesture. You moved the cello bow, you moved your arm. How can you call this imaginary space when you're in fact moving? Isn't there a one-to-one correspondence between a physical gesture and a musical movement? Well, the answer is that music is not the sounds you are hearing. The sounds you are hearing create the music, but the music is more complicated than that. When you think of a piece of music, when you listen to a piece of music, you are hearing the sounds that go by, but you are relating the sounds to sounds you heard previously. And if you know the music, you're relating the sounds to sounds you will hear later. I can demonstrate this for you very easily. How many people know this song? Hey Jude. Raise your hand if you've ever heard that song. Okay, I don't have to play any more of that song for you, And you are not going to take the entire 6.5 minutes to think about that song. You immediately think of the whole song in your head. So that piece of music has it's an object of a sort. This is a picture of a hypercube. A hypercube, like a cube, is supposed to have right angles. It has an extra right angle coming from every vertex. But of course, in three-dimensional space, this is impossible. If you were to hold this hypercube, you would see the cube right angles, but this extra set would have to go into another dimension. It isn't possible for us to actually see a hypercube or a tesseract, but this is the shadow of the tesseract. It is a three-dimensional shadow of a four-dimensional object. And if we want to understand what the tesseract actually is, we would need lots of different pictures, lots of different models of a four-dimensional object, and then we could maybe begin to see how all the pieces fit together. We could conceive of this. This is what happens in music.
Adam, I have to say, this is a two-dimensional shadow of a
Yes, I completely agree. Whoops. I completely agree. This is a shadow of a shadow. Thank you for pointing that out. Thank you. Yes, so if we were holding the hypercube, we would be holding a shadow. I didn't, unfortunately, have a hypercube to bring. I'm so sorry. But music is like this in that we, as I said, relate times the different sections of music together. If we have a piece of music, it occurs over time, but we relate this to this that we're going to hear, and we relate this that we just heard to that, and the interconnections go on and on. And as I said, as I just demonstrated, we don't think of it that way when we're thinking of a piece of music. We have all those ideas in our head at once. So we have to listen to music over time, but we don't think of it that way. So in this way, music is a four-dimensional object. So I wanted to introduce you to a different shadow of the music besides movement. This is music notation, and it is a code system that instructs a musician how to move to create a sound. It is very useful, but it's also very perilous. These 4 notes take the same amount of time to play as these 32 notes, so you can imagine how confusing that would be if you look at this and you think, well, yeah, but that's in fact the case. These are very fast and these are very slow. But it's actually worse than that. As a piano player, I'm looking at this music, and as the notes, I read it from left to right constantly. I never go right to left, always left to right. And the notes, as they go down, they go this way and they go up this way. Well, as a piano player, my hands are going right and left. So my eyes are going from left to right, but my hands are going both directions. And if notes are going up, I'm going this way. And if notes are going, and it's different for every instrument. The cello has its own set of challenges, the recorder. No sane person would have ever created this method to notate. It's a system that evolved over about 1,000 years, and we're stuck with it. However, it is useful and helpful because it allows us, in one glance, to see things about the music that we would have to wait to hear. So we can notice similarities in these notes with perhaps these notes here. We can see it all happening at once. This allows me as a musician, if I've never heard a piece before, I can look at a piece of music, and in seconds I can get a sense of what it sounds like, whereas it would take me minutes to play. This is even more useful in an orchestral score. This is what a conductor sees, or a composer who writes for orchestra. When they see this, every one of these instruments is playing at the same time. All of these notes are happening at once, from left to right. And the only way you can hear this, it is possible to do this. This is a skill I've learned. For instance, if I'm listening to the horns up here, I wish I had a pointer, but that's all right. Oh, maybe this. Yeah, here we go. If I'm listening to the horns, I get the sound of the horns in my head, and then I fix it in my head, and then I add the strings, and I add the woodwinds in. It's kind of like I freeze time to do that. But it's very useful and helpful to be able to do that. Some people are so good at this that they can look at this and immediately play it on the piano. I cannot do that yet. I'm still working on that. So I'm going to make the argument to you that music notation, just like a stick, is a tool. And so when we are looking at music notation, we are not simply using it as a way of understanding music. We are actually connecting. That tool becomes a part of our body. And we are actually moving physically through the music space. And as we said, this is not a space that exists in 3 dimensions, it exists in 4.
Why do you say it's 4?
Because it...
Time is 4th, but
Yeah.
why is what's the other 3?
The other 3, well, any physical movement that you would make. So there is an actual...
You say that music is in the physical...
Yes, because I have to play it. So
okay.
it's not that there is no 3 dimensions. You know, if I play this piece of music, get my pedal right. Yes, there is a physical movement happening here. But the element of time is the 4th dimension. And when I'm thinking about a piece of music, I'm not bound by time. So I can actually think back and forth, and I can dart at any point in time in the music. So I'm moving around through that 4th dimension at will. And because music notation is a tool, it's actually me that's moving through that space, not simply the music. And how does that help us play better? Well, if you can imagine somebody reading a piece of music for the first time and singing it to you versus somebody that knows the music very well, you may have had this experience, you may not be moved by the person that's just kind of reading through it the first time, and you may be very moved by the person that knows it. That's because they've made all those associations and they can understand everything about the music. They know how to express it. They know what that shape is like, and they guide us through it. So it's very helpful to have music notation in this way. Now I want to give you a chance to learn a little bit of music notation, okay? The first thing I want you to introduce my friend Ta. This is 1 beat, 1 sound per beat. And all I'm going to ask you to do, for now, is when I point to it, I just want you to say Ta.
Ta.
And not so hard, not so scary. Now, Ta can be right side up or upside down. It does not matter. What matters is that it's a dot and a line. Now I'm going to introduce you to a second symbol, and I'm only going to introduce you to 2 rhythmic symbols today. This is TT. This is called a quarter note, by the way, and these are 2 eighth notes. Does anyone read music in this room? Oh, wow. Okay, so a lot of you. For those of you that read music, maybe you'll learn about reading music in a new way. But for those of you that are new, I'm really glad it helps. So when I point to this, I just want you to say TT, please.
T. Ta. Ta. T.
Okay, and for those of you that don't read music, I'm going to introduce you to the idea of reading music this way. I'd like you to please raise your hand, and if I call on you, I'm going to ask you to either say Ta or TT. Volunteers, please. I do need a hand raised so it's not crazy. Yeah. So you say Ta or TT, your choice.
Whatever I choose.
Either one.
Okay, sorry, didn't get this.
That's okay, so choose.
Ta.
Ta. Okay. Someone else, please. Yes. TT. Someone else, please. TT. Maybe 2 more. Yes. Ta. Maybe 1 more, please. TT. Okay, so we've created a piece of music ourselves. This doesn't really exist anywhere else. I mean, of course, it may have been duplicated, but we know for a fact that it's new, that none of us have ever heard it before. Can we read this piece of music together? Ready?
Ta. T. Ta. T.
Okay, awesome, terrific, very good. So you can see, if you look at this rhythmic notation, that you can get a sense. You don't have to rely on time to understand it. You can look at it. You can see that there are 3 sets of eighth note pairs and 2 quarter notes, and it gives you a sense immediately of what the piece of music is, as opposed to waiting for it over time. Now, I want to introduce you to some friends of mine. This is where we get into the singing part of the presentation. I am not judging anyone singing in here. I don't care how well you sing. I just want you to please go through the motions with me and do your best. If you start to get an idea of where I'm going, I'd appreciate it if you would not spoil it for everyone else. But I want to introduce you to 4 friends here. Each of them is a melody, and I'm going to test your memory on this. I'm going to sing all 4 of these for you first, and then I'm going to show you them. Each is at a different color to help you remember, and has a different syllable. This one goes like this, and you don't have to repeat it yet. Oh, okay. This one sounds like this. Ah. Some of you already know where I'm going with this. That's fine. This one sounds like this. Ooh. And this one here sounds like this. Hey. So let's see how well you can recognize and remember these. to teach you this one first, and we have a lot of people I think who already know how to do this, so that's going to help. Would you please sing, oh, go. Very nice, very nice. Okay. And I'm going to have you sing this one. This one goes, ah, go. Do you remember this one? Good. Do you remember this one? Good. Can't fool you. Good, good, good. Okay. How about this one? This one goes, ooh, go. Very good. Do you remember this one? There you go. You got it. Do you remember this one? That's making this easy for me. This one goes, go. Do you remember this one? Excellent. Do you remember this one? Very good. And this one? I know this is difficult for some of you, but you're doing a great job. And how about this last one again? Go. Okay, so you need a little review. We're going to run through all four. One time. First one. Next one. Good. Third one. Last one. Okay, good. Please look under your chairs if you haven't already and find a sheet of paper. This is a piece of music, and those of you that read music will instantly recognize it. And those of you that don't may recognize it soon. If you do recognize it, I'm not interested in the words right now. I want to stick to the syllables that we've learned. As you look at this piece of paper, you will see the four phrases, and they're not in color, I'm sorry, but you can tell by the syllables which ones they are. And so here's what I'd like to do. I'm going to play this melody on the piano, and the parts we didn't learn, we'll just hum. And you can just listen to the piano and hum along, but what I want you to notice is, what are you doing with your eyes right now as you look at this piece of music? You're not looking at it, I would imagine, left to right, or even right to left, or up to... You're probably darting all over the place with this piece of music. That's what you're supposed to do. You're getting an instant sense of the structure of this piece. If this is a piece of music you know and recognize already, are you learning something new about it as you look at it in music notation? Are you getting a sense of freedom to move through the space of this piece of music? And if this is new for you, do you think you have some understanding of what this piece of music is even before you sing it? Even if it's a very rudimentary understanding. So I'm going to play this on the piano, and I would like you to please sing the syllables where you see them, and just hum where you don't, and then we'll see what happens. Ready? Go. And then hum. First phrase. Hum. Third phrase. Before we do anything like clap or say anything, take a second and look at the piece of music again now that you've sung it. Does this notation change the way you think about this piece of music now that you are outside of the gravity of time and you can just see it all at once. Do you have a sense of looking at the imaginary space of music from beyond it, seeing it all at once? This is not a presentation about music. This is a presentation about math. So I think I need to get to the math while I still have time. Let me check my time. Doing good. Why would we want math to move? Well, as Feldenkrais practitioners, we listen to Feldenkrais when he says movement is life. We know that as little children, as babies, before we can even talk, our first lessons are in movement. And one of the wonderful things Feldenkrais let us know was that if you can incorporate movement into learning, it greatly enhances your ability to learn anything. So this is why we want math to move, but as a matter of fact, math does move. How does math move? Does it move like music? No, it moves a little differently than music. Math, when I talk about the way math moves, it's hard to explain. Those of you that are comfortable with math may have a sense of the movement of math. I'm going to talk about it more in a minute. But I can tell you that math moves in imaginary spaces a lot. If you think about numbers that are too big to imagine, like the number of atoms in a star or the number of stars in the universe, we can't conceive of that number actually physically, but we can imagine it through mathematics. Mathematics can compress that number for us so that we can not only talk about the number, but we can manipulate those numbers, add them together, add the number of stars in two galaxies together. Mathematics discusses dimensions, 7, 9, 23 dimensions at once. It's possible with math to talk about dimensionality that is not possible for us to even contemplate otherwise, much less move around in. So there's definitely some imaginary spaces happening with mathematics that we are moving into. But let me talk about some physical movements that are not 3 or 4 or 9 dimensional. Excuse me. I want to show you some ways math moves in very basic ways. We're going to start with Newton's equation here, F equals ma. Now when we talk about movement in Feldenkrais, we talk about manipulation, orientation, and timing. And I'm going to show you how that happens with these symbols. In this case, I have F equals ma, force equals mass times acceleration, and I am going to manipulate this formula. I'm going to move this A over here, put it underneath the F. Can you see?
What each number, each letter represents?
Yes, F is force, as in how much force you need to move something. M is mass, how much mass something has. And acceleration is how quickly it accelerates under that force. So let me explain that formula if it's interesting to you. The formula says that the amount of force you need to move something is the same as its mass times its acceleration. Okay? But if I manipulate the formula and put the A over here, then suddenly it's not about the force anymore. Now it's about how much mass something has. So I've not only manipulated the formula, I've changed the orientation of the formula. Okay? And regarding timing, this isn't going to be very good for timing, but this here is. This indicates that one unknown is moving at a much quicker rate than another. As one goes up, the other goes up much more quickly. So there's an element of timing in this math notation that's interesting. So, are there limits to the way math notation can move? Is it really movement if it's completely free? In fact, there are limits. If you look here at this first one, 3 plus 7 times 2 equals 17. This is the parentheses rule we're talking about. We know that you have to do the math inside the parentheses first, or the numbers do not come out right. This is a rule we have created for consistency. For me, that's a little like saying you can't bend your arm past your elbow. There's a limit to what you can do. You have to abide by the laws of this notation. F equals ma, we saw, you cannot simply move the A to the other side. You cannot say, well, then FA equals m. That is not allowed. That is a limit to the movement in mathematics. And you see at the bottom, I'm talking about trigonometry of flat surfaces versus trigonometry of curved surfaces. I'm way out of my depth talking about that, but I do know that it requires a different use of a similar notation to do it. So there's a limitation to the notation of trigonometry of flat surfaces, which you can then change for the trigonometry of a curved surface. So these are limits to the way we allow ourselves to move with our mathematical notation. And you notice that we're using notation to talk about this. Math notation is a tool, just like music notation, that allows us to move through this math space. And if you, yes?
I'm not, okay, I'm trying to understand better what you mean by moves through math space.
Mm-hmm.
I mean, you're hinting to various things. One is actual movement
Yes.
of, take the A, put it there.
Mm-hmm.
And there are movements with constraints, etc.
Yes.
But it seems that you're actually hinting at larger dimensional space, and I don't really understand what you mean by we try to move through,
Well,
and how you connect to this.
so for me personally, as I connect to it, it is important for me to associate the movement of the notation with what's happening as a consequence. I actually have to imagine movement in this notation to understand what's happening in mathematics. This is probably a good place to talk about, I don't know, maybe it's not a good place to talk about. I'm going to mention Feynman. He created his own math notation system when he was a kid. He didn't even use the basic. He created his own because it allowed him to better move around through the concepts. So I may be taking some liberties when I talk about moving through math space, but what I'm trying to get at is that there's a way in which we imagine the concepts of mathematics moving around in our minds that is hard to explain, hard to describe, but you can see it happening to some extent in the notation. Does that make sense? And so the notation, as we know, if notation is a tool, our body schema takes the tool and it turns it into our body. So I'm going to argue that the math notation is not simply a tool that we look at, but as we use math notation, it's connected to us. We become that math notation, and we move around through that space. If you accept this idea, this enables us to do amazing things with math education. Now, so I want to do a little caveat. Let's say you have a great body organization. Does that mean that you should be able to move very easily through math? We know for a fact there's some people who are extremely well organized who have no math sense whatsoever. We know that there are people who have amazing math sense who are no body sense whatsoever. And there are people who are good at both, and there are people who are good at neither. So having good organization is not sufficient. You would have to work specifically with the organization of the person moving through math space, through this with their math body. How can you connect to the math space with the physical body? I have 3 ways that might be possible. The first way might be simply to consider, we've talked about math anxiety. As you're looking at math notation, do you immediately freeze up? Are you paralyzed? Do you get nervous? This is a way, if you can't even see the math notation, you're not going to be able to connect with it. So physically working with someone to address this image that they see, so that I had a thought actually that if you told a child, okay, we're going to do some math, but you're not allowed to move your eyes at all. You must keep your eyes very still. They're not going to be able to do it. As soon as you paralyze them, keep them from moving, they're not going to be able to think. They need to be able to move their eyes at least. So you might be able to wake them up to that idea that yes, if you want to do math, you might need to move your eyes around. You might need to move a little bit. It might actually be connecting you to what's going on. And it might bring their awareness to the fact that when they see this math notation, they freeze. I had a particular problem where my eyes, they still do this, but they used to jump from place to place. I could not smoothly scan from left to right. And as I improved that through the Feldenkrais method, I started to realize how important it was because my thought process was also not continuous, as my eyes were not continuous. I couldn't actually understand this simple sentence because I couldn't see all of it. I would jump, jump, jump. It was very disconnected. It was necessary for me to learn to scan carefully left to right to get the ideas that were in this, and also right to left, to be able to have a whole sense of it with my eyes. A second way we might want to consider connecting, this is a little more interesting, and this is something I experienced too. We know that in some math, like at the calculus level or above, there are different kinds of unknowns. An equation in calculus might have x's and y's, but it might also have deltas and epsilons. These are different kinds of unknowns that act in different ways. And in fact, they can be dependent upon one another. So if all I know how to understand is x and y, and I don't know how to understand limits and movements of delta and epsilon, it's almost like my elbow has this amount of freedom and none other. But if I understand that one kind of variable is dependent upon another, then it's a little more like my freedom of this joint is dependent on what this joint can do. And I might not have that sense in math if I don't have it in my body. So if I free up my body and begin to recognize that there's a dependence of one joint upon the other, I might be able to understand in math the dependence of one kind of variable on another.
Actually, Leonardo da Vinci discovered that in the 15th century.
Really?
Yes.
He beat me to it. Okay. Joy, do you have another question?
Yeah, I have a question.
Okay.
If maybe it's better to delay to the end of your talk.
Maybe we can do that. I'm almost at the end.
Are there any experimental studies on what you have just described?
Only the ones I have done on myself. And at the end, I will talk about that if you want. The third way I was going to suggest is that just simply having a sense of continuity, if you are lying on the floor and you can begin to, if you've never had a sense of continuity, if all your movements are jumpy and disconnected, if you for the very first time have a sense of a continuous movement going up as you go, continuous sense through your body from your foot to your hand, that may assist you in complicated math ideas, proofs for instance, that are continuous from the beginning to the end. Unfortunately in math, it's not like a novel where you can just kind of skip the boring parts. Everything in a good math proof is essential. And if you don't have a sense of continuity in your body, you may never be able to contemplate continuity in a math argument. So these are three ways in which connecting to the notation or connecting to what you see could be done in a setting of mathematics teaching. An example, for instance, supposing you have a student in like first year calculus and you want to teach them the proof of, sorry non-math people, this is, you won't necessarily know what I'm talking about, but the proof of the irrationality of the square root of 2. It's a very basic, very elegant, beautiful proof. So you ask them to explain it to you. You have them learn it, and then you ask them to explain it to you or to work it through. You might watch as they write out the argument and see where does the pencil slow down? Where does it get stuck? Where physically do they seem to show distress as they're moving through this? You might be able to pinpoint places where the movement is stuck. The movement through the proof, the movement through their body, the movement through the imaginary space. Isn't this just good teaching? I say that good math teachers are probably doing this all the time, but I'm not convinced that they know exactly what they are doing.
Sorry, what are they doing all the
I
time?
think good math teachers are actually doing these things that I'm talking about.
This?
All these things we're talking about. Like you may have a math teacher that works with anxiety or works with the body, or they may have a number of tricks they use on their students. But I'm not convinced that they have this in a systematic way, that they understand exactly what they are doing as they are helping their students. They just know it works. I'm suggesting that if these ideas have any merit whatsoever, and there's no research behind them, but they are ideas. If they have merit and they prove to be effective, we would then have something like a systematic means of addressing certain kinds of math issues. And we would know what we were doing, and then we could do what we want. So, the implications of this presentation, I hope, are that we can improve the study of mathematics in a systematic way and not have to be, shooting blindly. I would like to think that some of these ideas will work. They worked for me, and I can talk about that in a minute if you want. But before that, I want to say that for me, I like this because connecting math to movement not only makes the math more human, it makes it easier for a person studying math to feel like a human. It also humanizes the mathematics. It forges a connection between math and being alive and being human.